Okay, now we're ready to start a new section. We just saw in the previous section introduction to architecture and machine code and how it relates to C, and now we are ready to start some assembly programming. Okay, so this section is going to teach you about move instructions, not movie instructions, move instructions that move data between registers and memory and between registers themselves and what their operands. We are also going to see the various ways we have available to address memory, to specify memory locations. Then we're going to look at an example called swap that just exchanges two pieces of data in memory, and both for 32 and 64 bits. So that's going to be an opportunity for you to see the difference between 32-bit assembly in x86 and x86 64. Then we're going to look at arithmetic operations, how to use condition codes, how to do branches, how to write loops with assembly. Then we're going to end with switch statements. So if you recall from last section, we saw there's three basic kinds of instructions. Instructions that move data between memory and registers. Instructions that perform arithmetic operations, like addition, for example. And they could have as operands both a memory or registers. And then instructions that transfer control, instructions that change the flow of execution of your program in the processor. Okay, so now let's start. What we're going to see now is instructions that move data between registers and memory. There's two basic types of instructions. One is called of that type. What's called a load. A load takes an address as a parameter, goes to memory, gets the data stored in that address, and puts it into the register. Okay. A store does the opposite. A store takes a register as a parameter as well, and also an address, and takes the data of the register and stores in the specified memory address. And recall that memory is indexed just like an array. Okay, you have an array or a table, and there's multiple entries. You're going to access that using an index, and the equivalent of an index is in an array or in a table. The memory is an address, a memory location. Okay, so we saw briefly that last section that there are 8 general purpose registers in IA32. There are 8 registers. 6 of them, these 6 here, are general purpose, and these 2 here, the ESP and EBP, have special meaning, and we're going to see how they're special in a little bit. So there's multiple types of instructions to move data. They all start with these 3 letters here, move. Then this X here, which in fact could be either one of these 3, B, W, or L, depending on the amount of data that's being moved. If you use move L, L stands for long word, so you're going to be moving 4 bytes worth of data. Okay, if you use move W, you're going to be moving 2 bytes worth of data. And if you use move B, you're going to be moving 1 byte worth of data. Okay. Now, in move instructions takes 2 operands, where the data comes from and where the data goes to. Okay. So now let's look at the specific instructions. Move L, source and destination, so move data from the source to the destination. And these are operands. These are the source. This is the source operand and destination operand. Okay. And here's the type of operands that you could have in a move instruction. The first one is called immediate. Think of it as a constant. This is a constant data, constant integer data embedded in the instruction itself. For example, you could have x400 as one of your operands, and that only makes sense to be a source. It doesn't make to have a constant. It doesn't make sense to have a constant as a destination. So a constant can only be a source of your move operation. Okay. So now the other type of operand is a register. Okay, it could be any of the 8 registers here that we have. Okay. And for example, if we do move EAX, EDX, what are we going to be doing? So EAX and EDX are operands. So EAX in this case is going to be the source, and EDX is going to be the destination. And we're going to get the contents of EAX and store it in EDX. Okay. So as I said before, ESP and EBP are reserved for special use, okay? But they can still be used as operands. Now, the third and final type of operand in move instructions is memory. Okay? So, and since we're talking about move L and we move 4 bytes worth of data, it means that an address there is going to be specifying the beginning of this 4-byte words that's going to be used as an operand. Okay, and one way to use an operand is to specify memory operand. Here's an example: is to put, for example, a register in parentheses. When you're doing that, you're saying that EAX holds an address, and now the operand for your move operation is the data containing the address that is stored in register EAX. But as we'll see later, there's many types of address modes, many ways of specifying address. This is just one of them. Okay, so the many combinations of move instructions. So, for example, continue with our moveL instruction. So the source can either be an immediate value, a register value, or a memory value. Okay. Suppose that you have an immediate as a source operand, and then you can have a register as a destination operand. Here's what we have. We have 4 is that's an example here. I have an example here. 4 is a constant. So it is a source operand. EAX is the register, and what this is going to do is going to store value hex 4 in register EAX. Now we can also have memory as a destination. So if we do moveL, this constant minus 147 in decimal here, and store to EAX in parentheses, and as I just told you in the previous slides, this says that now we're going to store it in a memory location specified by the address stored in register EAX. Now continue our examples here. We could have register as a source and a register as a destination. That's the simplest case. That's a simple case, right? And here we're going to get the contents of EAX and copy into register EDX. Now we can go from registered to memory. So for example, we can get the contents of EAX and store into, remember this is in parentheses, so into the memory location specified by the address stored in register EDX. Finally, we could have memory as a source operand and register as a destination operand. This will be a type of load. You're loading memory into loading memory data into a register. Okay, so here we're going to get the contents of the location specified by register EAX and store it in register EDX. Okay. You cannot do memory transfer with a single instruction. So how would you do that then? Well, you move it to a register. You could get data from memory to a register. That's step number 1. And then you can get data from a register to memory. That'll be step number 2. That's how you move data from memory to memory. So now let's see what's the C analog of all of these operations. So here I have, for example, variable A that happens to be mapped in a register, and we store constant hex 4. And another example here, for example, I have this pointer P underscore A. We're going to dereference the pointer and say we're going to store the constant minus 147 into the location specified by pointer PA. Okay, so now since memory, that means that since this is a pointer, it's on the left-hand side, it's going to be the destination. That's why here in the destination we have a memory operand. And if we look at the address held by pointer PA, that's what's contained in register EAX. So now these other 3 cases here are also pretty simple. This if I had two variables mapped into register, var D and var A. We're just copying the value from var A to var D. And then here I have, if I have var A, which could be stored in a register, is stored in a register. And I copy into a pointer, same thing here, pointer PD. Since we're storing pointers point somewhere in memory, the destination operand has to be memory. And finally here, what we're doing is loading data. In this last example here, we're loading data from memory, so we have a pointer here on the right-hand side into a register, and in this case, var Ds happen to be mapped to a register. So let's look at the various ways we have to address memory. So these are the basic addressing modes. There are many others, but the first one is called indirect access. Indirect just says that now the register contains an address, and then we're going to use that, we're going to use the contents of the register as an address to memory. So memory, as we said, memory is just like an array. Okay, so that means that we have an index here, and inside this index is the contents of the register specified inside the address expression. An example here, I saw before, probably I'm repeating this for the third time now. This register ECX holds an address. Using the parentheses here, we say now we want the contents of memory whose address is stored in ECX. Now, this is a basic one. The other type of addressing mode is called displacement. And the way we specify this, we have a little, a constant outside our parentheses here. And all it does is it adds that constant to the base register. So register R specifies a memory address, but the final memory address is obtained by adding the contents of that register with this constant D. For example, here what we're doing is we're getting the contents of EBP. Okay, so the contents of EBP, we're adding 8. Okay, and we are using that as the address to memory, and we're storing that into EDX. Easy, right? So now let's use this basic addressing modes in an example. So here we have this C function here called swap that does the following. It takes two pointers as a parameter, and it gets the contents of XP, stores and stores into a temporary variable T0. It gets the contents of of the pointer YP and stores into temporary variable T1, and then stores T1 into XP and T0 into YP. So we're just swapping the contents swapping the locations pointed by these pointers. Now, as you see here, so okay, now this is the assembly version of our C code, the C code we just saw. And so we have three basic pieces here. One is called the setup. It's getting and reading the parameters and setting up the stack and so on. We have the body that does the body of the function, the body of the execution. And then we have the finish up, where we restore the stack to its original location, restore register values, and then return to the caller. So let's see how stack works. Now we have the body. Let's focus on the body here. That's the body of our swap function, and we have 6 assembly instructions. Okay, so let's go now step by step. And the registers we're using here, here's the mapping of register to values. So YP here happens to be mapped into register ECX. XP here happens to be mapped into register EDX. Now T0 was mapped into register EX, and T1 was mapped into register EBX. And this mapping is a choice of the compiler. Okay, the compiler chooses how to map the variables into registers. Okay, so now on the right hand side here, we have what each one of these assembly instructions is representing, and this is the state of our stack in the beginning of our execution. Okay, so now we are ready to see how this gets executed step by step. Okay, so now we have our registers. That's that when we begin executing, and recall that both YP and XP are addresses, right? So they're pointers. That means that they're pointers, so they're variables that hold addresses, and the addresses, the address of YP is 120, which is right here. So and that means that YP points to this location, and XP is 124. That means that XP points to this location here. And our registers and our EBP, our stack pointer, is located in address 104. So EBP points to here, and now we're going to see that a lot of values are relative, a lot of memory locations are relative to the stack pointer. Let's execute the first instruction now. When we execute this move here, what are we doing? Well, we are storing the contents of YP as a pointer into ECX. So since YP is stored 12 bytes away from EBP, we're going to use as a source operand the displacement address mode, right? A displacement address. So the way the address is obtained is by getting EBP, adding 12, and we're going to use that memory of that as our source operand, and then store it in ECX, and that's what happens. So we get 120 and store it in ECX. Great. So what we did there, we just got then the address of YP and stored in ECX. The same thing for XP, but now note that this changed to 8 now because XP stored 8 bytes away from EBP. Great. So now EDX holds 124, which is the address held by pointer XP. So what we want to do now is store the contents of the pointer YP into register EAX. But remember that we had just put YP into ECX, so now ECX holds an address. That means if we just use ECX as an address, we're actually getting the data pointed by YP. And since YP was held address 120, that is pointing right here. Okay. When we execute this instruction, we're getting the contents pointed by YP that happens to be stored in ECX and loading it into EAX. That's what happened here. Okay. All right, so now let's do the next step. We're doing the same thing for XP now. We're getting the contents of the address pointed by XP and loading it into EBX. But the pointer XP was stored in register EDX. So we use a memory source operand here to get that and store it in EBX. And so we get, and that happens to be, we have EBX, right, which is yeah, so EBX is a destination, EDX is 124, that's an address. We're going to use that to get, this is the address here, get that contents there and store it in EBX because that's the destination register. So what are we going to do now? Well, now we're going to get the contents of EAX, which was contents of IP, and store in XP because we're swapping it, right? So, and we still have the address of XP in EDX. So now we have this as a destination operand. So when we do that, well, what's going to happen? This gets updated with the contents of EAX. And same thing happens when we're storing to YP. And note that we just left the addresses of the pointers into the register because we use them to read them and then later to write to them.